Okay, this video is going to deal with how p orbitals overlap. So we have three, on an atom we have three p orbitals, which I drew in the other orbital. Here's one. We have one over here. So let me color them in like I've been doing. I'm going to use red and blue because I think that's how I made the exam questions. And this gets really hard to draw because I got one coming in and out of the plane of the board. So it's back behind and coming out in front like that. You don't have to be an artist and you're not going to have to draw these, but I'm drawing it one time. So we will refer to this drawing all the time. So here's my three axes. Here's one axis, the other axis, and the one coming in and out of the plane of the board. Hope you can visualize that. Okay, so we have two ways of adding orbitals again. So I'm going to look at an atom, it doesn't matter which, nitrogen or oxygen, something that has a p orbital in this direction. So I'm just going to look here. Here's one atom, and here's my p orbital. Not very well drawn, but who cares? Here's the other atom with the p orbital. So these atoms have gone from very far apart like this to they've moved close together and are now the orbitals are overlapping. So this is typically called the z orbital. The two the pz's from both atoms are overlapping. But that's a matter of choice, and we don't expect you to know that. So if I put my colors in, I'm going to have blue here for this orbital, blue here for this orbital, and red here. And again, color choice doesn't matter. I could have picked red in here and blue out here. It doesn't matter. I just picked this way. So we can either add them or cancel them in the middle. So if I add them, I get large overlap in the middle. So my molecule is going to look something like this. So we're going to get a big blob right here in the middle. Excuse me. Right there. So I'm going to get a big blob, which I'm going to label blue. And I'll have two red blobs out here, like that. My blue blob. And they could be switched. Again, the colors could be different. It doesn't matter what color you pick as long as they're different. And I get this molecular orbital. Here's my two atoms right there. These are not electrons. I'm just pointing out where they're at. Right here and right here. And I have this whole drawing is an orbital, and it's a bonding orbital, and it's a sigma orbital because the bond density is on the bond axis. That's what indicates sigma. Now, I could cancel these too. Let me redraw over here. Okay, there's my orbitals. I've redrawn them. Now, in this case, we're not going to add them. We're going to cancel on them. So in this position, right there, they're overlapping and they're going to cancel, so I'm going to subtract them. So in this part, it's going to go to 0 because they cancel out. So when I'm done, I get something that looks like this. Here's my one atom. Here's my other atom. Notice it's small on the inside here and larger on the outside. I probably overdrew the outside. Let me erase that. Okay, I redrew them a little bit more to scale. It's hard drawing these to scale all the time, and we're not going to ask you to do that. We are going to ask you to recognize these orbitals. So this is one big orbital. It is one. It looks like two separate, but it's one orbital. And so I'm going to have blue over here and red here. And when I'm done, I get red over here and blue over here. Okay? And I change the sign or the color of them because they cancel in the middle, so I don't want them to look like they overlap. This is called a node here where there's 0 electron density. Again, another term you don't necessarily need. So those are how the pz orbitals overlap. And this, since the bond density, the density of the orbital is on the bonding axis like that, we call this a sigma, and it's anti-bonding because there's no electron density between two atoms. It cancels out. That's why it's anti-bonding. This one is bonding because it has a large amount of electron density here on the bonding axis between the two atoms. This one has 0, goes to 0 here. Okay, so this is an anti-bonding orbital, sigma star up here that I've labeled. Okay, all right, so look at the other one for the other type of p orbital.